Hello guys, welcome to Pepcoding, and now we are going to discuss the next question, that is node to root path in a binary tree. So in this question we have to find the node to root path in a binary tree. So we have already done this question in our level 1 videos. So but in that case what we have done is we have passed one more argument, that is vector argument, that is vector. So we have passed that vector, and then what we are going to do is what we were doing in that case is we were filling that vector. Okay, so we were filling that vector and we are just simply returning it. But now what we will do in this case is we are simply returning that particular vector. Okay, so last time it was void type, but this time it is going to be of vector type. So in this case we are just filling it and we are returning it. Okay, so actually this is going to be this will change some flow. Okay, so now you will understand some another flow of this recursive call of node to root path. Okay, so that's why this question is in level 2, because we are going to discuss the next method. Okay, so let's see what is actually the node to root path of a binary tree. Suppose this is our binary tree and we have been given one data also. Suppose the data is 5. Okay, so we have to find the node to root path of this 5 node. Okay, so for this, first what we are going to do, we are going to find the 5 and we are going to we are going to add these all the paths up to root element. Okay, so how can we reach to the root? 5 9 7 2. So what we have to do, we have to fill this path in a vector, that is 5 9 7 2, and then we have to return it. Okay, so this is what the question is asking us to do. Suppose let me take some another path, another data, that is 16. Suppose the data is now 16. So what is the node to root path value? 16. We have to reach from 16 to 2, that is the root element is 2. So 16 5 9 7 2. So this is how we can reach to the root node. Okay, so let's see how can we do this. So first what I'm going to do is I'm going to implement one function, that is find data. So we have already implemented that function when we were doing when we were discussing the our first method. Okay, so we have already discussed this method. Okay, and now after implementing this function we are going to implement our second method. Okay, so I'm going to take the help of this function. So let's see how can we do this, and then we will understand the flow of it. Okay, so let me do this full screen. Okay, now I'm going to implement it bool and find data. Actually this function was returning the value true or false. If we have found that data, if we have found this data, then we are returning true. If we haven't found this data, then we were doing, we were returning false. Okay, so this was actually this function. So let me receive two argument, that is tree node star, and let me take with root node name and int data. Okay, so these are the two arguments. Now let me just quickly implement this function. So if node is equal to null, node is equal to null ptr, then what we have to do, we have to return the false. Okay, if node of val is equal to data, if we have found that value, that data, then what we are going to return, we are going to return the true. Okay, and then what we are going to do, we are going to use the two calls, that is left call or the right call. So if find data node of left or find, let me copy this name, find data and then find data node of right, comma, data. If any of this condition is true, then what we are going to do? We are going to return this. Okay. Hmm. So this was actually our that method. So let me take this and let's see how the code is flowing in this method. Okay. So this is our code, and now I'm going to try run this. So first let me create one stack for this. So this is our stack. Hmm. So first root node is in this position in 2. It is pointing to the 2, and data is, suppose the data is 5. Okay, data is 5. So these are the two condition which is checking whether the node is null or it is equal to node is equal to data. Okay, so if node is equal to, is node is equal to null? No. Node equal to data? No. What I'm going to do, I'm going to move to the left side. Again, not equal to null, not equal to data, then again we are going to move to the left side. So let me push into the stack, node of 2 of left, again 7 of left. Now we have reached to the 3. Then again what we are going to do, we are going to move to the left side, because this is not equal to null as well as not equal to data. So when we reach here, so we encounter the null. Okay, so we receive the null. So if node is equal to null, then what we are going to do, we have to return the false. So we have to return the false. Now we are going for the right call, that is also equal to null. Then again what we are going to do, we are going to return the false. So let me take one eraser. So what we are going to do, we are going to return false as well as false. So if both the condition are false, then actually it is going to return false only. Okay, so 3 way is going to erase from the stack. Now we are going for the right condition. So for 7, the left condition is false. Now we are going for the right condition, that is this one. So now we are going for the right, that is 9. Okay, so 9 is going to push into the stack. Okay, so let me erase this. Now we are going to checking for the 9. Okay, so again these both condition are false. So again for 9, I'm going to check for the left side. Okay, so when we reach it here, then we found 5. Now first I'm going to check this condition, is node is equal to null, that is false. Is node is equal to data? True, that is true. So what we are going to do is, see, I'm going to check for 5, for the left condition of 5, that is, and this condition is true. Okay, because when we use the condition for the 9, so it we have reached to the fifth, and this is actually returned the true value. Okay, so this is actually returned the true value because node is equal to data. So what is going to happen is, it is going to return true. Okay, it is going to return true, and now we are going to check for the right condition. So can you just think about this? Will we check the right condition? Because we have already found the true from the left side. Okay, from this condition we have already found the true. Okay, so do there is need for the right? No, because this is OR operator, and OR never check if we already found true in our first condition. Okay, so it will not move to the right side, because we have already found true from the left side. Okay, so the right call will not be happened. So now again it is going to return true. It is going to return true from here. Now this is false and this is true. So again what is going to happen, this is going to return true over here, and then in the end it is going to return true. So for 2, we have used the left call and we found true over here. So we are not going to move to the right side. Okay, now you have to analyze one thing. See, you have to analyze one thing, that is, now this tag will become empty, and now we have to analyze. See, what you have to analyze it, when you found 5, that is data, then how we are going is, we have found true here, then we reach to the 9, then we are just reaching to the 7, then we are just reaching to the root node, and this is actually our path. Okay, so how can we achieve, how can we just achieve our second method, that is how can we return the, let me take the pen, how we now we have to return the our vector. So we just have to change this return type. Now it is a boolean, so now we are going to change for the vector. Okay, and when we will find that data, then we are simply just what we will do is we will simply add that element to the vector. Okay, and it is only flowing to the root path only. So we are just simply going to add, when we found that data, we are simply going to add that add that node. Okay, again we found the data, add that node, again add that node. This is how we can find this path. Okay, so how can we do this? So let me explain you how can we do this. So if we haven't found the data, suppose if we haven't found the data, that is in this case, so I'm going to return the blank vector. Blank vector. If we have found the data, then in that case I'm going to add the node and then return it. So now the size is greater than 1. Okay, now the size of vector is greater than 1. So if we are using the left call and we're using the right call, and we have to receive some vector, if the size is 0, that means we haven't found the node yet. Okay, and if we haven't found the node yet, so we don't need to add our node element. Okay, so if the size is greater than 0, then what we have to do, we have to simply add the node. Okay, suppose in this case size of vector is not equal to 0 because 5 is added to the vector. So in this case we have to add the node. Okay, so let's see how can we code this, and in the end we are going to discuss it. Okay, so let me just change how can we do this. So instead of boolean, I'm going to change the return type, and I'm also going to change the name of it. Okay, so let me do this. Okay, so if it is null, then what we have to do, we simply have to create one vector of tree node. It is a base, and simply I'm going to return the blank vector. Okay, and if we found this vector, then I'm going to create the vector. Okay, answer name, and I'm going to add it, push back, and I'm going to add this node. Okay, and I'm going to return it. Okay, and now I'm going to use the left call and the right call. So how can we do this? So first I'm going to use the left call, that is I have to receive it tree node. So for this I have to receive it, so vector, and I have to receive it, let me take one variable, that is left. Okay, now I have to give the call for the left side, so node of left. Okay, now data will remain same. So if the size of left is not equal to 0, that is there is some element in the left vector, so what we have to do in that case, we have to add the element. So if left dot size is not equal to 0, then in that case we have to push back, push the element in that particular vector. So I'm going to push node and return, I'm going to return the left vector. Okay, now the same thing we have to do for the right. Okay, for this we have to do for the right element. Now it is for the right call, and we simply have to change the root node of right. Okay, we do it right here and as well right here, and we are going to return the right here. Okay, if both the conditions, both the vector are blank, then again what we have to do, we have to simply return the blank vector. Okay, so we haven't found the node yet. Okay, so now I think my code is completed, so let me call it from here also. So let me return root comma data. Okay, so let me run this and check for the compile time errors. So it is accepted. So let me just, what I'm going to do is I'm going to dry run this. Okay, so this time I'm going to do little fast. So let me remove this, all these. Now I'm going to dry run this. So actually the flow is actually the same. The only difference is of return type. Okay, this code is pretty much easy. So let me take this. Hmm. So this is our code. Okay, so for this what I'm going to do, I'm going to do directly without using this tag. Okay, so you have to imagine it. So again, this is not a null and this is also not a data. So we will move to the left side. Again, this is not a data or null. Then again we are going to use move left side, and again I'm going to use move the left side. Now this node is a null, so we have to return the blank array list, blank vector. Again, right side it is also blank, so we have to return the blank. Okay, so the call for 7 for left is completed and we have received a blank array list. So in this we are going to check the size. Now the size is actually equal to 0. Then in that case we haven't found the node yet, we haven't found the data yet. In this case we don't have to push back the node here. Okay, because the size is equal to 0. Okay, because we have returned the blank vector. Then again we are going to move to the right side, that is to the ninth part. Again it is equal to, it is these both conditions are false. Then again it is going to move to the left side. So if we move to the left side and we have checked for the 5, then it is equal. So what we are going to do, we are going to return, we are going to fill 5 node to this vector and we are going to return it. Okay, so in case of 9, our left call is finished. Now we have received this 5 in the left variable. Now I'm going to check the size. Size is not equal to 0. That means we have found our data. So in that case what we have to do, we have to push myself also. So I'm going to push it myself also in the left vector. So now the vector left vector will become 5 and 9 and we have to return it. So again it is going to return it without moving to the right call. Okay, so this part is actually important. So again we are just simply returning this. Okay, now we are in seventh condition. Okay, so we are in 7th. So we have actually used the right call. So this is for 7. We have received the 5 and 9 in right variable. Okay, so again I'm going to check the size and its size is not equal to 0. In this case we have to push myself into this vector and we have to return it. So I'm going to push it 5, 9 and 7. Again I have pushed it. Now 2 is for the left call, so it is going to receive 5, 9 and 7, and again it is going to check the size and it is going to push himself 5, 9, 7, 2, and now it is going to return it from here. So at the end we will receive this answer. Okay, so let me check for all the test cases whether they are running successfully or not. So all the test cases are running fine. So thank you guys for watching this video, and we'll meet in the next video.